Dear students, we are going to start with our first example with the angle bracket. Our learning targets is a basic modeling and meshing and the effect of refining the mesh and getting to know the Hyperview environment. Here you can see the bracket and how it's supported here and how the force goes into this bracket on the top side. Okay, we will start with going to the Hypermesh desktop and selecting Optistruct as a solver. And now we are going to make a collector for our components, our 2D components or 3D components most likely, because we would build everything on one face, so without any set direction. We generate a collector, we generate a component, we call it 2D surface, and we get it to a certain color which is different to the normal setup. So you see this is now highlighted because it means it's my current component. Otherwise every new item I generate is going to be in this highlighted component. So you have to be very careful where you put your, or when you generate new items or new things, so that you have the component active you want to have it in. Okay, first I want to create the nodes which are needed to generate the face. So altogether there are 12 nodes. I have to go to geometry, create nodes, X, Y, Z. So I put in my first number at 0, 0, 0. I create it. Now I put control and click very fast, or just once on the middle mouse button. Then we get recentered. So now we are getting to the next position, 100, 0, 0, 100, 100, and to 50, 100, and to 0, 50, then 75, 125, and 75, 100, zero, 25, then minus 25, 25, then 47.5, so this is a corner, and 50, and now it's 50, so now it's really where the radius of the corner, the center of the radius is located, 25.5, and now 47.5 and 25.5. Now this is the center. Now we are starting to generate the lines. First we want to highlight the node numbers. There are two ways to do it. I can here click on the node numbers. I can select all of them and put it to on. Now you have it all selected, or you go to geometry, check nodes and numbers, and then you're on the same menu. Okay. now we are going to generate the lines. We go to the line menu, geometry, create lines, linear nodes, so linear connection between the points, the node list 1, 2, and you can click the middle mouse to generate it. 2, 3, 4, 11, 10, 5. Return. So now all lines are generated. Now we are going to generate the circles or part or arc center and radiuses. So now we are going to create lines, arc center and radius. So here I'm going to the z-axis. It was originally that way, so with 3 points you generate a surface, but you want to have it in everything in the z surface, and we are putting in a radius of 25. We don't have an offset, and we have an angle of 90 degrees, and we are going to generate the first one with 0.7. Generate, and then now we put an offset in. The offset is 90. In the documentation the offset is -270, which is the same, and now I'm going to the 8.8. I keep the same way, and now I can put the offset at 180 in again, generate this one. And now I have to go to this guy, which is number 12. I select radius of 2.5 millimeter, and I have to generate an offset of 270, which is -90, and I was wrong, 2.5. Put this as a sender, and it's created. Now I return it. So we have now all lines for this surface generated. Now we are going to generate the, first we want to check the line numbers. So we are going geometry, check, lines, numbers, all selected, and now you also see the line numbering. Now we are going to generate the surface. So we go to geometry, create, surface, and what we select is spline fillers. And you see you have to put all the lines in. So start, and now you see what I did. I forgot that guy here. Put all the surrounding lines in, and I generate the surface. It's generated, but you don't really see it. So I want to go to this wireframe display type. Now you can really guess it's in. So now I think you still realize that you can also put that like in the documentation, but I think it's better this way. Now we are going to add the cutouts, so the 2 holes into it, which are on 0.7 and 8. So we generate them, create lines, circle, center, and radius. So I get this guy here, and it's a radius of 15. Create it here, create it, return. So now I have 2 circles, but it's still not cut out. So the next part is to trim my surface. So it's going to geometry, edit, surface, trim with lines. So I select here my surface and my line, I trim, and you see that there's 2 additional surfaces now visible. I can go now to geometry, delete surfaces, but I show you something different. you're going to Tool, and you're going to Delete, and surface is already selected. Or something really cool, you go, this is brought across here, it's Delete, so you go instantly to that, select them, return. So now we have the geometry, but there is still we want to generate fixed points. It means like where we can select the mesh density, where we can select certain identity, where the surface or the mesh later doesn't forget that this points here existed before. Actually, it's not points in this notation of Altair, it's nodes, and we are generating now fixed points. Okay, how we are going to do that? We are going to Geometry, create fixed points on surface. So we click on the surface and we click on the nodes, but we will put all of them on and acknowledged by the middle mouse, pressing the middle mouse button, and we are going to return. And now we are going to delete the nodes. Either we go on this here, this navigation system. Sometimes it needs a lot of time to find stuff, but I think geometry, delete nodes, and you select all and clear all. No, you select all and you clear them. Now they are deleted, so just the nodes on the surface remain. So here you can really see the remaining fixed points. Okay, now we are going to mesh. We generate a mesh collector, create components, and this is for the 2D mesh. And you see it's already active. We are going to F12, which is auto mesh. We use not mixed, it was before, so we use quad 5, and we just mesh it like it is. We could change now the number of meshes on these lines, but we will do it later. So we're going to return. So we can change the color of this one. Now we can show it by component. Okay, so one moment. Okay, so still the mesh was generated in the 2D surface. So we are going to organize it now. That's the reason I was a little bit silent. Now we are going to organize. Select all elements and we move them to the 2D mesh collector. And we're going to return. And we are looking at you see it now, it's getting now the color of the mesh. If you change that, just change it. So everything is fine now. We meshed. Now we have to generate a material because everything is based on material. So we go to material create and we call it steel, and we put it on my material 1. That's the easiest isotropic material, and we have a E modulus of 210 and a nu of 0.3. That's standard, but you have to confirm it. Now we have to generate which is something called property. At the moment we know how our mesh looks like and we know our material, but we don't, for example, don't know how thick our material is, because we have just a 2D surface and we just have 2D mesh elements, and those they have to know the properties. So we generate properties and we call them, I don't know what we want to call them, like bracket prop. We give it a different color so we can distinguish it, and we are going to, we call it P shell, and the thickness is 5 millimeter, and we have a material and we use the steel one. If we have multiple materials, so we can have the same thickness but a different material, for example. Okay, now we generated that one, and now we want to assign the property to the 2D mesh, and we assign it to break prop. And it should be bracket okay, you see you can also rename it. And now we are going to have loads and constraint. So we start with the collectors. So collectors create load collectors. So constraint is the first one. The name is a little bit different to what we used in the script. I don't want to irritate you, I just want to show you that it's not really needed to name it in the way we used it. It's always your choice. So now I make the boundary conditions, I add the constraint, so I click on all these guys here, and there are different ways of select. In the tutorial it's also like degree of freedom 4, 5 and 6, but you can you don't need it because we couldn't hold it anyway in this direction, because the nodes actually they are able, its shells are able to do it in some direction, so we click it on, we confirm it, and now you see I have to maybe increase the size, that you have this constraints of all directions and all moments, all rotations now on this nodes. So next thing we are going to do, we have a collectors, create load collector. The second one, this one is for our force we are going to put in, but first we also create a new assembly. You see it's also the right mouse button, you can generate it, and we call it RPE3. That's rigid body, and it's 3 the RPE2 and RPE3. RPE3 is more flexible. We will see how we are generating it. It's a 1D mesh, so we are going to go to mesh, create 1D elements, RPE3. So we put the nodes and all freedoms in, and we have all the same weighting factor. I will show you in the lecture something where it is different. So now we generated the independent node, we're going to return, and we see whether it was generated in the right collector, the right component. Okay, so I don't have to use the organize for this guy. Now I'm going to put the load on, so it's a boundary condition create force. So I select this guy. This is what's written in your documentation, and you see is a force direction hitting this RPE3 master node. So next thing is we are going to add the load steps. So we are going to set up its create load step, because for example you can have multiple things calculated. Oops. So this is I call it bracket load step, and analysis type is linear. Let me see, linear static. The SPCs I collected, it's a constraint, and the load is load collector. SPCs means it's the boundary conditions, it's create constraints, so the SPC is constraints. I will tell you later what it means, SPC. And now we are more or less done. We save our model, save as model. We use whatever, new folder, FEM, tutorial, and then I generate a subfolder, chapter 1, and this is version 1 of that. Okay, now we should be ready to go. Very quick check. We call it, see it whether it changed, but property material. Let me see, I want to change the color of the material. Yeah, it's fine. Everything is linked. For assembly, we don't have assembly. So everything is fine. Now we're going to analysis, Optistruct, hit the Optistruct button, and it should run. Yes, and now we are going to look at the results. So now you see not much. We can here it's, you can guess that it's a movement of my part. I can magnify it, factor of 100 for example, and I can put the speed down. It's this guy here. I zoom out, and so this is how the part is going to bend, but it's as a factor of 100 in. But we can also put a color on it. Oops, a moment. We can put it on the displacement color, or also the element stresses. And there's some amazing part we have at this corner. He has high stresses, but we see later how we are going to deal with it in the second part of chapter 1.